This is week 5. Lecture 5 tonight deals with the data dictionary and several other miscellaneous Oracle topics. It's kind of a catch up of Oracle things in the textbook until we get us ready to do the last couple of chapters that we have in this block. So, the page numbers are referenced out to page 173. All right, hope you remember from last week that we use commit to make changes permanent in any changes that we make to an Oracle table. And we're going to find out a little bit later that there are more things that we can do to a database along with the commit command. Now, the book points out, and you might have a tendency to use something called auto commit. But there's a problem there. Auto commit says as soon as the data has been entered, it will automatically commit it to the database. And so at that point, you start to have a little issue of, all right, who's responsible for what's going on? If we use the commit command, and you do it every time, then you know you've got that authority or someone you have assigned has got that authority. When you turn on auto commit, Joe Bag of Donuts could come in, type something onto your Oracle screen, and commit it without you ever knowing it. So it's kind of a good thing to use that manual commit. That commit updates the changes, but it also makes them public. And keep in mind, we talked back several weeks ago that you can have records locked, and they can be locked to the extent where you're the only one who is seeing them. And that data isn't updated until you make that commit command. And again, the same thing happens if two people have a record open. The first one to make that commit command has the upper hand, shall we say, in Oracle. If you make them both at the same time, then other things will happen. So commit can be a very, very important tool. I worked with a guy that when he entered data, he would enter one entity instance of data, if you will, and commit it to make sure that data was there and accurate. So that's one way to do it. Not one I would necessarily select. Well, on page 175, we look at the insert statement, and we saw this last week. Let's do a quick review. What does line 2 and 3 tell you about this specific insert statement? You're putting something into every field. So we go ahead and we run this command, and we use commit. After we run it, actually that commit was run separately, but it could be run as part of that command that we're operating. Or we can use the commit icon. And you can see I've got it circled up there in the top where the icons are, and it's a little check mark with the database symbol. And here you can see the commit action was taken. All right, we're adding information technology, and we committed it, and now we're adding the legal department. So what can you tell me based on the two pieces, or these two pieces of code, would you expect to happen in that departments table? Well, there are 3 columns, right? And I'm going to see all the information. But look here, that's what I'm looking for, Faith. It's on mine, and it shows up under my data tab. The way I'm looking at all the data, Lee, is I went and I clicked on the data columns down in the view grid. And so that'll bring up all the data for that specific database if I've got it selected on the left-hand side. But Faith is absolutely correct. The information technology is going to be there. I have not committed the legal department yet. So that brings up the next little icon that we want to look at, and that's called the rollback icon. So I go ahead and click on that rollback icon, or don't do anything and just get out of that table, if you will, and the legal department is gone. Information technology is there because we took the commit action. And again, that commit can be done either by the icon if you're working in this type of venue, or as an actual code icon. So Where that's leading us to in the latter part of page 175, we're not limited to just one type of transaction. We can do inserts, we can do updates, and we can do deletes. Now, a couple of things that we need to think about as we go through here. First of all, if you're running a query that's doing an insert, if one insert fails, all the inserts have failed. One of the things that happens periodically is students will go in and play with the script that loads the database, make some changes to it, and then try and run the database program again, and nothing will load. And the reason it won't load is that if you have one value that errors out and you haven't committed all of those values, then none of them will appear in the table. It'll stop everything. Now, we can do a commit or a rollback, and let's talk about those a little bit. We've seen what happens with a commit. That's going to finalize the data, and that puts it in there, and it can't be taken out unless we do some other sort of SQL function with it. We can also use rollback, and rollback is what happens when we use this rollback icon and eliminate the legal department. It takes away anything that has not been committed. And that's an actual command that we can use, rollback. So we can do that again by an icon if it's available to us, or we can actually put the command in. If you remember a couple of weeks ago when we took a look at the script that built the database that we're using right now, SQL Fun, at the very end of each of the tables there's a commit. So it'll create the table, it'll run the insert statements, and then it commits those insert statements. So that way you know you have a table there. The other thing it does, and when we do a commit, it creates within the background of Oracle a rollback point. And so we can go through, and if our database goes totally squirrely for some reason, or we run into a network failure during a major update or reading data in, we can always go back to the last commit that was created for that database and pick our database up from there. Now, that's really an administrator's function. I don't go any further into it than that. The problem with using a rollback point is that everything in front of that point, everything that was done after that point, even though it may have been entered, will be erased. All right, now I'm looking at the Data tab, if you're playing along there at your console, and I've got the Data tab up, and we're looking at Amy Johnson. All right, we're looking at the data table for checking accounts, and we know, and we can see right here, Amy Johnson has $5,280.25. So again, the way I'm bringing this up is if I double click on the table in the Navigate window, I can bring up the data and look at all the data that's available within that database. Now, we're running a commit, and we did that just to clear up things from page 175. And notice what we're going to do. We're going to update the savings account, and we're going to set the balance to minus $500 for Amy Johnson. All right? And when we go through and we look at that again, there's Amy Johnson at $357. So we've taken her money away. So it's been updated. Now we're going to add it back in, and we're going to commit it, and Amy's back up. So we can commit that increase again, or we can add that money back in, we can commit it, and that absolutely makes sure that Amy Johnson has her $5,280.25. We're saying the same thing several different ways, but the key to pull out of this the first part of this lecture is that you have to use that commit command to make sure that the data is locked into the Oracle table that you are either inserting, updating, or deleting. Now, this one gets to be kind of interesting because we can do an update or an insert with a view. And we talked before a week or so ago about a view actually gives us some security to what our users can do as far as changing, adding, or deleting data. This is really a wise thing to do if you're not the only person that's modifying the database or being able to add records. Where they have large data warehouses and they have somebody that their job 8 hours a day, 5 days a week is to fat finger data into tables, they normally will give them a view that they will work from. So they don't necessarily see all the data that's in the table for a specific item or a specific individual. Now, along with that view, we've seen how we can read the data. We can also delete data through the use of a view. But the key becomes it's going to include the columns that can't be seen in the view, but it'll only include the rows that can be seen. So let's back up a second and look at how that might work. Let's say that we wanted to go in and we create a view where all we see is the customer and the balance. And we come down to Amy Johnson, and Amy has left the company. So we're taking away her company checking account. Now, all that we see on the screen is Amy Johnson and $357.26 in this example. When we delete Amy Johnson, we're also going to delete her account ID, which is column 1. Even though we don't see it, it'll also be deleted because we're actually deleting the Amy Johnson entity instance in the table. All right. So you can use a view to update or delete or modify a table. So again, you want to be very cautious in who you give authority to delete things out of your tables or out of your database. And it can get you into a world of hurt. So we can do just about anything with a view that we can do with our normal commands. I mentioned last week, and I'll mention it again this week, SQL Developer, Toad, several of the programs out there allow you to go in, if you have the authority, and modify the data within a table without writing the commands and bypassing all of the checks and balances. Don't do that. And I know a couple companies that have, and in one case they ended up having to reestablish their entire database. It got so screwed up. And of course, when you go in and enter that data in a table in Oracle, there's no record of that happening. There's a record if we run a commit. We can go back and look at commits if the administrator has set up the data files correctly. But if I go in and arbitrarily audit a table, then nobody's going to know who did it or when or where. So again, I highly recommend you don't go in and modify tables or allow people that are working with you, if you work in an Oracle environment, to do that. It just leads to a lot of problems. All right, we talked a little bit about views last week, and we're going to get into them just a little bit farther. And if you'll remember, normally when we set a view up, we're going to use the keywords create or replace view, just to make sure that we have the most accurate, up-to-date view in the system. Now, you would think that every time you create a view, it would automatically erase it, but that's not necessarily the case. So again, good Oracle developers will use create or replace the view when they start, just like good Oracle developers will drop a table before they create it. Oracle doesn't error out if there's no table there, and you're just safe and you don't have any leftover data or code hanging around. So this is really a very simple view that we're creating. Remember, it's a select statement, and this is coming out of Section 505 employees. So this is going to create a view, these attributes, employee ID, first name, last name, department code, and credit limit. Pretty simple. And when we take a look at that, based on the information we've put in, we're looking at the shipping department. So we've got Martha, Dan, and Fred, and everybody's credit limit is $25. Pretty simple. Do I have to do a commit with the view when I write it this way? Great. Good head shake. Thank you, Marie. All right. Now we're going to insert into that view the following values. Now, notice that we're inserting data to every column that's available in that view. Let's back up a second. There are the columns we're using. Employee ID, first and last name, department code, credit limit. Employee ID, first and last name, department code, credit limit. First name is John. Yes. All right. Now, could I insert only the employee ID, John, Patrick, and Ship, and not insert his credit limit in the current view that we're using? Well, null is one way to do it. What's another way I could do it? Exactly correct. Identify only the attributes in the view that I'm going to update, and then I can update that view. So when you think about using a view, it's just like using a table. Just like doing an insert into a table, except we're limiting, again, what our end user can see. And there we go. We've got John added in. He gets his credit limit at $25. Now, I've got an update limit here. We'd have to commit John if we were done, but we're not quite done yet. Line 6 through 8, we're going to do an update, and we're going to use that same view. And this time, for whoever employee 203 is, we're going to update their credit limit to $35. Now, we haven't used the update command very much, but based on your where clause or clauses, you can go in and update just about anything that you want to. Also notice at the end of Chapter 4 and now in Chapter 5, we're using the set command. And that's setting that attribute to equal that specific value. All right, and that's what we're going to look at in a minute. As you can see here, we've gone through, we've updated Martha Woods to $35 on her credit limit. Right now, if we closed out the database, what would happen? It would go away. Nothing would be changed, and our buddy John Patrick would be out of there. By the way, you'll notice in the upper left-hand corner, I have the refresh button highlighted as you saw last week. As you saw last week, sometimes the data will come up, and sometimes you have to refresh the table so it will come up. Remember the refresh key. All right, page 1, we're still on page 185, and now down at the bottom, we're deleting from the view employee 208. So let's look. That was Fred Campbell. Bye, Fred. And we go and look, and Fred is now missing in action. But we've refreshed it. What haven't we done yet? We haven't committed. All right, and now we're going to go again on page 187. Now we're going to change the code to marketing for employee 207. Now, think a second. How are we doing all this? Through a view, exactly correct. All right, through a view. So now we go through and we updated that employee number, and look what happens. We've lost another employee. Again, though, if we don't commit this, none of it's valid. It's all going to go away. Right, now we're going to go one more step. We're going to insert into the view these values. And we've got Susan Manning coming in with a credit limit of $50. Wait a minute. What happened to Susan?
She's not in this view.
Why not?
She's not shipping.
Ah, very good. Didn't catch anybody. She doesn't show up. We're allowed to update because we're updating all of the columns that are available within that view. But she doesn't meet the criteria to be displayed within the view. All right. And I think the textbook just leaves us hanging. I don't know if we ever do commit those people or not. Okay. Yeah, I actually wrote to this guy, and because later on in the book, well, in chapter 1 there's a couple of errors, and later on in the book there are some more errors. The check option, you can only use an insert, and an update can only be used when the resulting rows will be in that in view. So you can only make the changes in what you see. This is a very good idea, and obviously the check option was not in effect because we were able to add Susan in. We didn't get any error back, so old Fat Finger Freddy that Lee just hired could put a mistake in and make Susan an executive instead of a shipping clerk. You never know what happened to her. Well, you would when she didn't pay her bill at the cafeteria. All right, always check to make sure the view's created. We're kind of wrapping up this part of that chapter. I'll look under the views if possible. Remember, an SQL developer, it's going to store it in a separate folder. It's not going to list everything together. I'm going to see if that view is there. If it is, and I'm creating a view by that name, I'm going to check and make sure, hey, if I got the right name and am I really supposed to get rid of this view? And then I'll use the create or replace to prevent any errors or problems happening. Now, we're going to change gears a little bit, and we're going to talk about the data dictionary. And this is a system catalog. And this contains information about all of the tables that are in your particular system. It's going to contain the database structure. You can take a look. There's a table on 196 that talks about everything that you can glean out of these data dictionary tables. But we're only going to look at a couple of the things right now. Well, that's interesting. That's a red rectangle. And there's the data. There's the data that goes with it. Okay, if you have SQL open, you can try to do this if you want. If not, I want you to try this on your vSphere machine at home before Thursday night. There are a couple of different ways to do this. One is to click the plus and play with the connection that way. The other option is to right-click on functions and then log in as system, and your password is Oracle. That's been established beforehand. And then what happens is you get access, you get access to all of the Oracle background tables that are there. And it talks about a whole bunch of stuff that you don't want to know about, but it also has some very good things for us, and that's what we're going to look at now. Within that Oracle information, within the Oracle Data Dictionary, we have a table called User Tables. And so we can write a select statement against this information, just like we can anything that Fat-Fingered Freddy put in. We can query that information with a select query to find out what's going on. By the way, no, it will not let you do updates, deletes, modifies, anything like that. You can just select. When we do that select, this is what we get, a list of all of the tables that are assigned to the specific database that you're logged into. So in our case, it's the SQL Fun database. And yep, sure enough, there are all of the tables that are in it if you scrolled all the way down to the bottom of the table name. Also, when you take a look at the results pane, one of the things that you may not have noticed before is that we've got a couple little icons to help us out. In this case, it's an A to Z or Z to A icon. So you can go ahead and press that, and instead of writing the code, remember ASC or DESC, up or down. We can actually do that with an arrow if we're not interested in having that come out or being done through the code. So that's kind of an easy way to help you look for any data that you might be going after. If we can do that for tables, we can do that for views also. So same thing, all we're going to do, page 199, is we're going to change the select the tables to a view from user views, and sure enough, there's our user views, and including some of the ones that we just finished working with, like row 9, 0506B in the shipping department. All right, so again, we can see a good deal of information about the tables we have created or have already been created in our database. Again, at Tinker, when I was hired to come in and convert an Access table to an Oracle table. And my first day on the job, I went to the boss and I said, "Tell me about the Oracle tables." "Well, I don't know about them. That's why we hired you." I said, "Well, I don't even know what database you're hitting. Do you know what database you're going to use?" "Nope. That's why we hired you." So I ended up getting permission to go in and look at the tables and their definitions to try and figure out what tables we were going to use to do this conversion project. You've heard enough about that before, so we won't go any further. But this, in the data dictionary for your specific database, can tell you all about how that database was constructed. We're selecting the view, and this time we're going to take a look at section 0513. So what it's telling us in a text value is exactly how that view was created. And if you would bring this up and scroll all the way across, you'll see the complete select statement that created view 513. So again, if you're hired on to Chesapeake and they tell you go learn the database, one of the things you want to look at is query the system tables and look at the views and look at the tables and how they were built. And it'll tell you a lot about how that database functions. We can also do a command called describe. And we talked about that just briefly at the beginning of the semester. But here we're telling it to describe one of the primary tables we use with this book, the L underbar employees. And notice what it's done. Down in the data grid, it shows us the names and it shows us the primary keys, what values have constraints against them, and then the type of attribute that is. So our employee ID is a not null and it's a number. So we know that's a number value that'll go up to 999, and it has to be filled in or it's automatically generated when they put it in. We look at first name, it's a varchar2 in 10 characters, last name, varchar2 in 20. The department code is a numeric value, varchar2 with a 3. What else could that be if it's always limited to 3? That could be a car also, because we're always going to have 3 characters for our department code. Date is something we'll talk about next week, I believe. And then we're looking at the credit limits. And what does the credit limit number 4, 2, what's that telling us? $99.99, and the last 2 values are decimals. Total of 4 digits. Yeah. All right, and then number, that's simple. Manager ID is going to be a number because it's actually the employee ID. Now the book jumps around a little bit. Now we're going to talk about constraints, and a constraint is any rule that's going to restrict data. So the primary constraint that everybody thinks about is a primary key. where a primary key uniquely identifies an entity instance in a table. And that constraint for that primary key says that primary key can be used once and only once within that table where it's functioning as a primary key. Now, where people will get confused is they'll have a different table where it's what we would call a foreign key, or a visiting key, if you will, and that can be repeated as many times as you need to. Because it's a foreign key, it's not acting in a primary key role. We'll see that one little bit later when we go further. A constraint usually requires that there are no nulls within that attribute. So again, we just talked about the employee ID. We're looking at a value that has to be filled in every time you commit that tab. Employee ID, not null, number 3. That's going to end up being your primary key. Okay. Now, what we didn't print out is the rest of this, which shows that it'll identify what your primary and foreign keys are. That part we didn't print out. Okay, and again, in the parent table, the table where this value is functioning as a primary key, only one row can have that individual number. So if Lee's employee ID in our class is 201, that means James can't be 201 also. It has to be a unique value. Let me digress a second. There is a function in Oracle that will go through and analyze sequential primary keys. Sequential, 1, 2, 3, 4, 5. And if you've gone through, and let's say your database is rather old, and you have primary keys 1, 2, 1010, 1013, 1000, whatever. Oracle does have a command that will let you recycle those primary keys that have been deleted and let you use them again. Bad idea, because then you start to get confused, because when Oracle recycles the primary keys, it reassigns all of your entity instances beginning with 1 and going forward. So where Lee was 201 and James was 202, and now we've recycled our primary keys, Lee is now 1 and James is 2. So you can see the problem that can get you into if you have queries based on certain primary keys and then you go through and change them. Because the one thing Oracle won't do is cascade that change down into your query. When we talk about database planning, you plan for that. And you think about, all right, how many employees am I going to have? How many items am I going to sell in my store? And the first database I developed for my wife's store, she had about 250 items. And she said, well, you don't need to design that item code to where I've got to enter up to 5 numbers. And I said, yes, I do. And when she closed, she was topping out at the max on that 5 numbers from different products that she had carried and wanted to track over the years. Some books will teach you that. I recommend don't use it, don't even learn about it, because the temptation was there. And it can be done, and you can lose a bunch of information and end up literally having to go through and rewrite every query in your database that had any kind of reference to a primary key. And I had somebody once ask, well, isn't that job security? Well, temporarily, yeah. All right, here we are. We're looking at constraints now, and we're going to get more into user constraints a little bit later. But in our systems tables, in our data dictionary, we can find a table called user constraints. And in this case, we're looking for any constraint that's established for the L underbar food table. So this is run just like any other query, and now it'll come up and tell us what the constraints are. By the way, you'll notice that for, let's see, the constraint name here, PK underbar L underbar food, that stands for primary key. FK stands for foreign key. So when you see a PK, you recognize that as probably the primary key within the table that you're looking at. When you see an FK, that means it's a foreign key. It's a primary key taking a trip to another table, if you will, to visit. Now, this is a coding constraint that would be placed on you by the company that you work for. There are different ways to identify those constraints. In fact, once we get done with this part of the lecture and take a break, we're going to look at some of those different constraints and ways that can help us when we're coding. But for our book and the data we're looking at, this 8 weeks and in advanced database, PK will always be a primary key. FK will always be a foreign key. That is a primary key that's in another table and being used in the table that we're working with. Well, this we're taking at user constraint columns. And there's a constraint name. We're looking at who owns them. Remember, you, in this case, are the DB user in this database, all right? So, and we're looking at this as the system administrator. So DB user is the owner, and you can see the constraints that they've created, and you can see the tables and column names that they're assigned to. By the way, you'll notice position. And we haven't looked at that before, but theoretically, that is the position of the column when it was created. The product code was created second. The primary key, the next one down, supply user ID, was created first. It's kind of interesting the way they created these as they set it up. And notice our check foods, it's not really a constraint, so we don't have a position on it. All right, what I've done in this is here's the listings of the Chapter 5 lab work for Thursday night. Some of you have had problems with the different editions of the books, so I've written them all out. Well, I copied them. All right, I copied them out of Kendall. So here's all 4 of the assignments, and they'll be out, or they should be out in D2L right now. So you can take a look at them. You can print them off when you get home if you want to, and that will be the work that we'll be doing Thursday night.